Look at portions of radiuses and chords in a circle. The line that goes from one edge to the other edge is called a chord on a circle. And so a special one would be if it goes through the center, it happens to be a diameter. So this is going to deal with a radius or some radiuses and then a chord that connects them. All right, that is going to make an isosceles triangle, basically, because if this is a radius and that's a radius, then these have to match, and that might come in helpful later on. Also, this length here is got to be the same as this, because once we know one radius, 15.2, then we know every radius is 15.2. Well, that lets us solve these first few because they're going to give you this helpful little piece over here. If this is 6.3 and this whole thing is 15.2, we're just going to do 15.2 minus 6.3. 15.2 minus 6.3, and we get 8.9. Well, that's what that length is here, is 8.9, because it has to add with 6.3 to match these 15.2 since they're all radiuses. So go ahead and try 49 for me, trying to find this part, knowing that that's 14.4, and this whole thing also has to be 14.4. Go ahead and pause the thing and try it. All right, if this is 14.4 and this is a total of 14.4, then that means that x is equal to 14.4 minus 7.2. That's just 7.2, so this length here is 7.2. Now, you may, as we go along, we will not have that helpful piece of information. So looking up through here, we start losing it here at 55. So now we're looking at our problem. We have a few things to think about. First off, every radius is going to be equal. Next off, the radius on the inside is going to cross our chord at 90 degrees on each one of these problems, which means we can use Pythagorean theorem when we need to. If we look at this one, we need to. So we know 11.1 is a leg and 14.3 is a leg, and we don't know the hypotenuse x. So we're going to do a squared plus b squared equals c squared. Remember, I like to use the shortest leg for a, the middle, the other leg for b, and then the hypotenuse has to be c. So we're going to do 11.1 squared plus 14.3 squared equals c squared. So 11.1 squared plus 14.3 squared is 327.7. So 327.7 equals c squared. Square root both sides. So square root that. 18.102, so 18.1. Is that a reasonable length? 11, 14, 18.1, yeah. 11.1, 14.3, 18.1. Those are reasonable. All right, so for the rest of the problems, you're going to have iterations of the Pythagorean theorem, and sometimes you'll have to use the fact that radiuses match in order to find other pieces. So for instance, on 58, try this one on your own. If that radius is 14.7, we know this radius is 14.7, so we have two parts of our right triangle. Try it. No, remember, you're solving for a leg, so you'll have to make sure that you have a squared plus b squared equals c squared. Pause me and try it. Okay, so now I'm going to use 6 as my a, so I've got 6 squared plus x squared equals 14.7 squared. So 36 plus x squared equals 14.7 squared, which is 216.1, I'll call it. And then subtract 36 from both sides. I get 180.1, so x squared equals 180.1, square root both sides. X equals the square root of 180.1. 13.4. All right, does that length make sense? Yeah, it's the leg will be shorter than the hypotenuse, but not a lot shorter. All right, so the rest of the problems in this section are like this. You have to use the fact that your radiuses match and Pythagorean theorem to figure out some kind of unknown. All right.